So I'm sharing the questions. I'm sharing the questions based on B.S. Lamberts law, the one which we were doing last time. If you remember the equation, what was the equation? Okay. Yes, the equation is A equals to epsilon. Epsilon is the Greek letter which represents a constant here, Cl. What was the meaning of epsilon? Molar absorptivity, because this is absorbance versus concentration. And here this equation indicates that absorbance is directly proportional to concentration. So you are getting a straight line. It's a straight line curve where the y-intercept here is 0. So starting from when the concentrations are 0, what is this? This is calibration. Remember I told you about the calibration, that first you have to fill water into it and then see the absorbance. So generally the graph will start from here, from here. When the concentration is 0, then absorbance is also 0. Yeah, ready for this question? Read the question. So Aditi, you are familiar with this graph? Absorbance, molar concentration. So the student is doing visible. Visible means that it must be a color solution. He prepared a set of cobalt to chloride solutions, and then he measured the absorbance with this wavelength. You can see that this is the wavelength which falls in the visible range. What was the visible range? 400 nanometer to 800 nanometer. So the wavelength is perfectly all right, 510 in between this. Then he determined the absorbance of unknown concentration. So what he did, he placed all these substances, all these solutions of non-concentration, and he made a straight line. And then he placed his unknown concentration in the same instrument. And when he was making this standard curve with the standard solution, there was an error here. You can see the error. This is not falling on this point. So the concentration is high. This is high concentration, higher than this, right? Concentration is high, but absorbance is low. So they're asking what can be the reason for that. At this concentration, the graph is out of line. There is error. You're getting low absorbance. Low absorbance means, is this concentration this or lesser than this? Low absorbance. Low absorbance, absorbance is directly proportional to concentration. If absorbance is less, then concentration must be less. It means the solution is not exactly this much molar. The solution is less molar. The solution by mistake has more water, right? It's less concentrated than 0.05. Am I right, Naisha? The solution is less concentrated. Naisha, is it okay? So what can be the answer? The answer will be yes, Aditi, very good. A. Yes, Anil, A. Because B, if you look at the B error, you are adding more concentrated. Then the point should go up here for the B. This is B error. For the C error, you are taking a longer path length. You know the equation A equals to epsilon C L. You're taking a longer path length. If L is more, what happens to absorbance? More. So again, it will go up. For the C, C is also higher absorbance. D, you didn't run the blank. If you have not run the blank, then the absorbance of this and water will be added. Then it should be again higher. So you can see that B, C, D, they all are reporting higher absorbance, higher. So they cannot be the reason. The value should be above this point, here, like this, higher range. So any questions here? Is it clear? Okay, I'm going on the next one. Check this one. Read the question carefully. This is again colored solution. Again, the absorbance should be in the visible range. And the visible frequency, visible wavelength is, yes, children? Visible wavelength range is 400 to 800 nanometer. You can see that they have selected the wavelength. Lisha, if you have any questions, please start asking. You joined slightly late. Check the wavelength of absorbance. 435. Wavelength of absorbance is 435 nanometer. That's okay. It's within this range. Oh, 453, sorry. Yeah, 453. That's quite within the range of your visible. Good. If the absorbance of the mixture is 0.20, how many moles of Fe3 plus were present in 100 ml of sample? Very simple question. Yes. First of all, the absorbance is for what part of the reaction? Is it for this one or this one? For which one? The absorbance is for this one or for this one? Look at this. The dark red species. This one. This absorbance are for the colored species. Naisha, you're listening? Lisa, you're there? Yeah, please ask questions because you joined slightly late. You missed few important points. So this one is going to be colored. So these absorbance colored, see dark red. So the absorbance are for this. He's saying 0.20. Ashlisha, the absorbance given to you is 0.20. So where is 0.20 here? This is absorbance. Here, Ashlisha. Then you drop a perpendicular like this, bring it down. So what's the concentration of your FeHCN2 plus? Now, do you know the concentration? 0.20. What's the concentration? So the concentration of FeHCN2 plus is 4 times 10 raised to power minus 5 molar. Very good. That's the concentration. How many moles of Fe3 plus? This is Fe3 plus. How many moles of Fe3 plus? You know that molarity is moles divided by volume in liters. So you can get the moles of Fe, HCN 2 plus, which you can convert into moles of Fe3 plus. That should be the answer. Can you do it? Give me 1 second by the time you are solving this question. I think Aditi is already answering. Check her answer is right. Okay, I'm back. Is she right, children? Yeah. See, all of you are giving this answer. So you have to just plug in the values, plug in the molarity. Volume in liters. Volume in liters. They have given 100 ml. So it is 0.1 liter. So it is 4 times 10 raised to the power minus 5 moles divided by 0.1. So moles are 4 times 10 raised to the power minus 6. Now in 1 mole of this, 1 mole of this, let's see this again. In 1 mole of this, how many moles of Fe3 plus? 1 is to 1. Check the ratio. That's why the answer is this. These are the moles of Fe3 plus. Is it okay? So answer is, we are good. Moving on to the next question, assuming that you have understood this. Naisha, finding it difficult, please start asking questions. Question 4. So copper 2 plus is a colored solution. This one is a colored solution, blue colored, blue. Its absorbance are given at different concentration. So you have the uh, standard curve, right? Now, when you are looking at this data, as the concentration is increasing, absorbance should increase, right? But they are saying, if you look at that 4, experiment 4, the absorbance is 0.680. Okay, let's see. Let's see what is the problem with the data. That's what they're asking. What's the problem with the data? So as the concentration is doubled, absorbance is nearly doubled, nearly, right? This is doubled. This is nearly doubled. But is this doubled? This one? This is double. This is not doubled. What is it? How many times it has increased? 0.15 divided by 0.1, 1.5. So 0.520 plus 0.520 times 1, your 1.5. How much is that? How much is this? Is it this? I don't think, right? It should be 0.78. Yeah, near about. It's not exactly, near about. So Anil is saying that this data should be 0.78. But it's not 0.78. The expected value should be 0.78, but it's 0.68. What can be the reason? Absorbance is low. Error. Absorbance is low due to, check. Remember longer path length? Longer path length means high absorbance. If the solution is very saturated, then saturated means high concentration, high absorbance. The concentration of solution is actually lesser than this. Yes. So answer is D. Only Anil and Aditi are answering. Lisa, start answering. Ashlisha, answer the questions, please. But can you tell me why I didn't discuss A? I didn't touch it. Why? Because the equation is temperature is the part here? Is there a temperature? No. So that's why temperature has no effect. Whether it is high temperature, low temperature, it doesn't matter because temperature is not the part of your absorbance, right? That's the reason. Okay, moving on, children. Oh, these are the only questions of the Beers-Lamberts law. So are we ready for next unit now? Unit 4. You have any questions from Beers-Lamberts law? Aditi, Naisha, Lisa, Ashleisha, any questions? Okay. Do you want to cancel a class on Thursday because of the Thanksgiving? Then you can let me know on WhatsApp, okay? I think we should not cancel it because as it is, we are with some problem with the syllabus. We have to move faster. Unit 4. Yeah, but I could not rearrange it because some children they were refusing to come at the time when I was asking. Yes, Anil, they were AP questions. Anil is asking the questions which we were discussing, they were of AP type. Yes, they are. They are of AP type. Okay, children, this particular unit 4 is very important. It's going to trouble you till unit 8. So you can see that generally this unit, whatever questions you are doing, limiting reactant, molarity, concentration, dilution, reactions, acid base reactions, net ionic equation, oxidation reduction, how to balance them, everything is coming in this unit. Everything. So I want you to pay more attention. It's a simple unit if you keep working with me. I'm asking questions, try to do it on the paper, then answer here in the chat. Keep asking your questions. Nothing tough here. Naisha, nothing is tough, okay? Keep asking your questions. Ready? So, first, I'm going to give you a brief idea about types of reactions. The unit 4 is based on chemical reactions. I think it must be written here. Yeah, chemical reaction. How many types of reactions are there? One reaction you have already done, that is combustion reaction. Do you know what is combustion reaction? Combustion reaction, yes, children? Burning in the presence of O2, yes. Any reaction like A in the presence of O2, you call it combustion. B in the presence of O2, like this. So all the reaction in which the second reactant is O2 is combustion. This we have done in unit 1. Remember empirical formulas, molecular formulas, how to work out the molecular formula of an organic molecule from combustion analysis. All these things we did. Like if I say H2 plus O2 is H2O, is it a combustion reaction? Is it? Why not, Anil? Aditi, is it a combustion reaction? No, Aditi, no. Combustion reaction doesn't mean that you will get CO2. You will get CO2 if carbon is undergoing combustion. Here there is no carbon. Aslesha, is this reaction a combustion reaction? Oh dear. Why? Why are you saying like this? For the combustion reaction, one reactant must be O2, oxygen gas. Is it there? Is one of the reactant O2? Yes or no? So it's a combustion reaction. And Anil, it doesn't matter whether they are gases, liquids, or solid. Like I give you one example here. Magnesium, solid. You have taken this solid magnesium ribbon. The picture is there in the books. You burn it in the presence of O2 gas. It's giving you MgO. I'm balancing the equation. Solid as ash. Ash can be one of the product in all combustion. You must have seen that how that wood after combustion giving you ash, carbon, unburned carbon is there. So this is solid. Is it a combustion reaction? Yes. So Aditi and Anil, please understand it can be solid, liquid, gas, and it can be anything formed over there. These are oxides. All combustion reactions will give you oxides. Oxides of that element. Oxide of hydrogen is water. Oxide of magnesium is magnesium oxide. Is it okay? I'm giving you one more reaction. CH4 plus O2. This is a gas. This is a gas. You are getting CO2 gas and H2O liquid. How will I come to know that I'm getting CO2 and H2O, nothing else? Because whatever elements are present here, okay, I have to balance the equation. Yeah, now it is balanced. So what are the components of this molecule, this one? What are the components? Carbon and hydrogen. Carbon will give you CO2. Hydrogen will give you H2O. So carbon here is giving you CO2 and hydrogen here is giving you H2O and nothing else is formed. It's a combustion reaction. So now let's define it. That combustion reaction is the reaction of burning in the presence of O2 gas. That is air, right? Air has O2. So one of the component of the combustion reaction is always O2. It doesn't matter what all other things are there. If you see O2 as one of the reactant, straight away classify it as combustion. We are clear about it? Okay, good. Now I'm taking you on the next type, synthesis. Next type is synthesis. Synthesis reactions when A is combining with B, giving you C. Only one product. So when two or more than two substances, no one is going to ask definition. So that's why I'm not going to spend much time on this. Just giving you hints because when you open the book, these words are written there. Only one product. Naisha, only one product. See, you are not getting more than one product. So let's come back on our combustion. Is this a synthesis reaction? This one? Yeah, it is synthesis. Why? Because you're getting only one product. See? Is this a synthesis reaction? This one? Yes. That is the reason these definitions are losing their importance. Like here, I can call it as combustion reaction. I can call it as synthesis reaction. And you know, children, I can call it as redox reaction also, reduction oxidation. So one reaction can be classified into many categories. That's why the importance of these words, they are losing the importance in learning process. Okay, so we are okay with synthesis definition. Let me give you few more examples like N2, nitrogen gas reacting with hydrogen gas. Naisha, you're writing everything? Write, speak, and type here in the chat. Best learning process. Your brain will become very active if you are participating in all the events. It's NH3. It's 2NH3. Now, what is this? Is it a synthesis reaction? This one? Yes, it is a synthesis reaction. I'm getting only one product, right? But it also falls in the category of oxidation reduction. That also we are going to learn. So these are combustion, synthesis. Then there is one more important term which you will see in many reactions or in many books, and is called as decomposition reaction. Okay, Afan, no problem. You can ask questions. Afan is joining us late because of some reason. So children, we can help him with his questions, right, Afan? Please start asking questions. And children, when you are asking questions, I've heard from many students that they are slightly hesitant in asking questions because they feel that question is not of very high quality. It doesn't matter. Okay, we are learning, and please don't hesitate in asking, even if you feel that it's a silly question. Let it be. Okay, silly questions, very small questions, very simple question can make you learn very big things. And if you avoid them, if you don't understand and not asking, then it can collapse your learning. Okay, so be ready with questions all the time. Keep asking questions. It will make your class more interesting also. Third type of reaction. So combustion done, synthesis done. Now third. Third, you will see decomposition. It's a very popular reaction. We are going to do many decomposition reactions. Decomposition. You know the meaning of decomposition? Decomposition. This is I. Breakdown. Yes, Anil. Breakdown. Decomposition means breakdown. Now you take any synthesis reaction, the one which you have written on the top, synthesis, is actually reverse of synthesis. Reverse of synthesis. You take any synthesis reaction and just write it in the reverse manner. Like for example, I can take this one, right? And now the reaction, I write it in the reverse way. So it is water which is undergoing breakdown to give you H2 and O2 gas. This is decomposition of water. Yes, it is. Yes, 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 Safan, very good. You start with one product, one reactant, sorry, not product, only one reactant. And then you are getting multiple products, two, two or more than two products. Combustion, synthesis, decomposition. Combustion, one of the reactant must be O2. Synthesis, start with two, three, four reactants, but giving you only one product, only one. Synthesis. Decomposition, reverse of synthesis. You start with only one product, start with one product, only one. Oh, I'm sorry. Again, I'm saying the wrong thing. Only one reactant, not the product for the decomposition. One reactant, and it will break down into multiple products, and that will be your synthesis or decomposition. Synthesis and decomposition are reverse of each other. Yes. Ready for questions? I'm going to give you reactions here. You have to identify them as combustion, synthesis, and decomposition. Here comes first reaction. KClO3. giving you KCl plus O2. I'm balancing the equation. So it is actually 2 here, 2 here, and 3 here. What kind of reaction is this? Oh, you have already started writing. Naisha, it is decomposition. One reactant giving you two products, decomposition. But if I write down this reaction in the reverse manner, what is it? Synthesis. So, do you agree with this term that decomposition and reverse and synthesis are reverse of each other? See, this is synthesis. This is decomposition. But do you think this falls in some other category also? What can be the other category for this one? Mhm. Yeah, combustion. The second reaction is also combustion reaction, this one, burning in the presence of O2. So this is the brief introduction of three types of reactions, which I don't think except combustion, synthesis and decomposition. Decomposition was very popular reactions earlier, but from last many exams, I have observed that they are not asking the name of the type of the reaction. Okay. There are few things which are important, which I will cover definitely as they come up. More important is oxidation reduction, precipitation, solid formation. Precipitation, the double displacement, single displacement type. Oxidation reduction, precipitation reactions, and acid base reactions. They are more important. We are going to learn that in this unit in detail, in depth. So, very first thing, we are dealing with chemical reactions. Here is a question. Please try to answer. It's a simple question. Think about it and answer. There is a beaker, a fun. Try to answer this question. It's a very simple question. If I give you NaCl solid, NaCl solid plus AgNO3 solid in this beaker, they are lying here together. The solid is lying here. At the bottom, solid is not in the air, right? It's at the bottom, the latex. Remember the word latex? All solids have latex. All solids, ionic latex, molecular solid, molecular latex, covalent network solid, covalent network latex, metallic solid, metals, metallic latex. So all solids have latex, right? So this is a solid. Do you think reaction, they will react with each other? Yes or no? This solid will react with this solid. Mhm. If I keep two solids together, will they react? No. Yeah, you're right. They will not react if you seal it completely, seal it so that water vapors from the air are not going there. No one is touching them because we need some motion. Solids, they don't have, they have very mean position vibrational motion. So NaCl and AgNO3 cannot collide with each other so nicely. If somebody says reaction will take place, maybe after 10 days, 15 days, but immediately there is no reaction. Am I right? But if I add water into it, water, as you add water, the solution becomes like you get a aqueous solution here. I'm making this aqueous solution. This is aqueous solution. And slowly you will see that your these substances will dissolve. Dissolve means dissolution. They will split apart. NaCl solid in water will completely split apart. Completely. 100%. like this. This dissolution process, if you remember, we discussed in Unit 3. Yes, aqueous, Ashlisha. Remember dissolution, delta H of hydration. Why this dissolution is taking place? Because the hydrogens of the water, hydrogens, are taking away this Cl minus, right? This one, see? Hydration. We used all these words: hydration, dissolution, delta H of hydration. We discussed in Born-Haber cycle also, lattice, all these things we did in Unit 3. Remember that? So Na plus will taken away. See, they are taken away by oxygen of the water, because plus minus. See how it is, they are getting hydrated, surrounded by oxygen of the water. Cl minus surrounded by hydrogen of the water. You already know. So what's the meaning of Na plus aqueous, children? That's an AP question. What's the meaning of Na plus aqueous? Is it isolated Na plus? No. It means that there is Na plus surrounded by water molecules like this, OH2. Oxygen is partial negative, right? Hydrogen partial positive. OH2, OH2, OH2. Each Na plus is surrounded by 6 water molecules. 1, 2, 3, 4, 5, 6. And then oxygen has partial negative on every water molecule, that you know. Water is polar in nature. So it's making a kind of attraction with the Na plus. Who is going to tell me the name of this attraction? What is this attraction called as? Remember, you have done so many names: hydrogen bonding, dipole, dipole, induced dipole, and ion dipole, induced dipole ion. But Aditi, induced dipole is there in non-polar molecules. Right now, you are dealing with water. So, what is the attractive force in water? Hydrogen bonding and dipole, right? So, it's not making hydrogen bonding. So, what is it making? Dipole. Hydrogen bonding it makes with itself. Na plus doesn't have any hydrogen on it. So, can I say ion dipole? Please know this name. AP question. Anil, ion dipole. Na plus and water. Na plus is ion, water is polar dipole. I'm not saying hydrogen bonding because Na plus cannot make hydrogen bonding. Which one is stronger? Ion dipole or dipole dipole? Which one is stronger, children? Remember the Coulomb's law? Ion dipole. Ion dipole is even stronger than hydrogen bonding. Children, is this question clear? That when these ions they go in the water, they make ion dipole attractive forces and they get hydrated. Is this picture clear, children? Naisha, is it clear? Because no one is answering. Afan, clear? Niza, Ashleisha? Unit 3 dissolution. Watch that video again. Yeah, Lisa answered very correctly. Ion dipole. Very good. Similarly with Cl minus. Cl minus is here. This is ion, this one. You can see this Cl minus here. Negative charge. This is ion. And these are water molecules with dipole. So what kind of attraction here? Ion dipole attraction. Ion dipole. It's a question, AP question. Okay. Now when I added water, we are back to the solution, children, here. When we added water, NaCl split apart like this. Please understand this very well. And what happens to AgNO3? It's also going to split apart. Ag plus aqueous, NO3 minus aqueous. Here also you have ion dipole, right? I want all of you to make the picture, the way the picture is made here, over here, this part. Show you again, this part. Make the picture of the hydration of nitrate in your notebook. Can you do that? Naisha, let's do it. Let's write down nitrate first. All of you are making it. NO3 minus. It's a negative ion. So it will be, who will come first? How you're going to write water? H2O or OH2? What is the right way of writing? What is the right way? Anil is saying H2O. What about rest of you? You know the charges on hydrogen and oxygen in water? Yeah, it should be H2O. This is wrong. So if somebody asks you to draw the hydrated ion, which can be an AP question. As I said, AP is more into understanding the microscopic picture. Microscopic, what is happening inside the solution. You will see in this unit, I'll show you many pictures. So this is like this because hydrogen is partial positive, oxygen is negative. What kind of attraction is this? Can you name the attraction, children? Can you name the attraction? Yes, it is ion dipole. So this will be surrounded by many water molecules. The number can be very big. That is the reason it's still very happy coming out of the AgNO3. Like this. See? This is called as, what is the other name for this process? Hydration. Hydration. Please do not forget this word, hydration. It's the formation of attractive forces, is exothermic. Heat is released. We are good with this? So what is happening to NaCl? Is getting dissolved, giving you Na plus Cl minus, completely separated. Nothing doing with each other. Where did I write OH2? Anil is asking a question. Let's see. This is negative, Anil, right? This is hydrogen, positive. This is hydrogen. Who is asking? Aditi. Okay, sorry, not Anil. Aditi, this is hydrogen. This is hydrogen. See? This is hydrogen. Check. This is hydrogen. So orientation will be like this, Aditi. Right? If it is Ag plus, let's draw Ag plus to be more clear. We all are making Ag plus. So with the Ag plus, who will come first? Oxygen. It's like this. Because oxygen has negative charge, right? This is called as dissolution, hydration, like this. Okay, so we are clear about the dissolution. This is something which we did in unit 3 also. Hydration, dissolution. It will come again in unit 6. Everything is interrelated. Okay, so when I put NaCl, is getting dissolved completely, 100%. AgNO3, 100%. Is going to present in this form. Now, what is there in the beaker? In the beaker, we don't have this solid. There's nothing. I'm making the beaker again. I'm showing you the picture of the beaker with water now. And I'm showing you water here. This is water. In bulk, the solvent. Now, what is present in this water? Do you have this NaCl solid? No. Do you have this AgNO3 solid? No. What is there? Can you name the ions present in this water? What is present in this water here? Yeah, any one of you? There is no solid. They are completely dissolved. So what is there? Yes, very good, Aditi. Na plus, Cl minus. Let me use some other color. These are the ions. Na plus, Cl minus, Ag plus, NO3 minus. And what are they doing? They are moving. They are aqueous, moving. And when they are moving, this Ag plus, when it comes closer to Cl minus, all of a sudden, this Na, it was NaCl solid with, no, now it is aqueous, right? Aqueous. AgNO3 aqueous. Now see, the reaction will take place. And silver will be happy to combine with chlorine. And it is not soluble. Okay, Anil, good. And it is no, see, I just looking at a word, Aditi and Anil. So that's why I'm using names wrongly. Anil, that's nice. Good. Now this AgCl is solid, right? And what else is there? NaNO3. But this NaNO3 is not solid. It is still aqueous. So what happens after the reaction? AgCl will precipitate down because it's not soluble. It will precipitate down like this. And this reaction is called as double displacement reaction. Double displacement. Can you explain how it is a double displacement? Why this reaction is double displacement, children? Naisha, you are going to answer this. What is happening to Na, Naisha? Lisa is saying, yeah, very good. Na is replacing Ag, right? They are replacing each other. Na is going to NO3 and Cl is replacing NO3. So they are interchanging their places. Yes, yes, right, Naisha. Good. So we are going to learn this more in depth. Now let's come to very simple understanding after dissolution. This slide is actually for dissolution only, meaning of the dissolution. Now we are going to learn electrolytes. First of all, electrolytes are ionic compounds. They are ionic compounds. If you have a covalent molecule, then it's not an electrolyte, it's non-electrolyte. Like C6H12O6, it's a glucose, it's a non-electrolyte. So ionic compounds are electrolytes. Electrolytes are something which gives you ions in the solution. So these ionic compounds, they give us ions in water. You must have heard electrolyte word from the doctors also. Take plenty of electrolytes. So what is that? That you take water, add salt into it. Some salts, right? Eating salt or different types of salts are available nowadays. That's an electrolyte, not sugar. We add some sugar also just to make it tasty. But sugar is not an electrolyte. So ionic compounds, they contain ions and they give ions in the solution. This solution is called as electrolyte. The word electrolyte has come from electricity, that when ions are there in the solution like this one, then they can move and conduct electricity. I think this condition I told you earlier also. electricity can flow only by any one of you, by moving, Afan, by moving charged particles. Please write down if you don't remember this. This we did it in metals. Metals are good conductor of electricity because they have free electrons moving in them. Yes, Afan. So write it again if somebody is forgetting it. So now do you have these charged particles which are moving here? Do we have? Yes, they are moving. So they are electrolytes. They can conduct electricity. But these electrolytes are divided into two categories. One, strong electrolyte, very strong electrolyte. Second, weak electrolyte, weak. What's a strong electrolyte? It's an ionic compound. It's an ionic solid. They all are ionic. It's the one which is 100% dissociated like ions, dissociated into ions. What is a weak electrolyte? Is only slightly, not 100%, is not fully 100% dissociated, not fully dissociated. I can write like this, slightly dissociated in into ions. Definitely both of them are ionic solids. But you remember we were writing the double displacement reaction of NaCl aqueous. So when you write AQ here with ionic solid, AQ with ionic solid, it means it's 100% dissociated fully. AgNO3, this is also ionic solid, is also AQ. AQ means 100% dissociated. So if the reaction is given and you can see that there is an ionic solid with this AQ word, take it as a strong electrolyte, strong, very strong. They fall in this category. The one which is fully soluble in water. I'm writing this word also. Completely soluble in water. Completely soluble. Electrolytes, we are working with water, children. Solvent is water only. Completely soluble in water. Can you complete this reaction, children? If you remember, we did it on the previous slide. Naisha, do you remember the reaction? Double displacement, interchange, take care of the charges. Na plus will go to NO3 minus, will make NaNO3 aqueous plus Cl minus will go to Ag plus. Metal should be written first, so Ag will come first. AgCl. You remember this is the one which was not soluble, solid. Now, what is this? NaNO3 aqueous. Is it a strong electrolyte, weak electrolyte? Afar? Is it a strong electrolyte, weak electrolyte? Strong. Very good. This is a strong electrolyte because I have written AQ here. AQ means completely dissociated because AQ is written. What about AgCl? This is not soluble, see? But it's an ionic solid. It's ionic. Ionic solid insoluble, but it doesn't mean that it's not going to dissociate. Some amount of AgCl will dissociate to give you Ag plus and Cl minus. So it's a weak electrolyte. NaNO3 is strong electrolyte. So how to identify strong electrolytes, weak electrolytes? Strong electrolytes are, so I'm talking about Ashita, ionic solids, ionic compounds. You're right, you're totally right. Weak acids, strong acids, they all are soluble in water. But they are not ionic compounds. They are not metal with non-metal, right? So right, that's why I'm writing every time because I know this point is there. So that's why I'm writing ionic, right? So ionic solids, ionic compounds, if they are completely soluble and they have written AQ next to them, then you take them 100% dissociated and then you can call them as strong electrolytes. But again, ionic compound, see how the flow chart is going. It's giving you ions in the solution, but it's not soluble. Means you're getting solid written next to the solution, solid, in the solution, solid. So there is some dissociation, some part is coming out, but rest all is in the solid form. That's a weak electrolyte. I think I clarified this question. It's a very good question what Aslesha has said. Now it should be clear to all of us that we are talking about ionic solids, not acids and bases. Acids and bases, they are soluble, but some of them are weak electrolytes, some of them are strong electrolytes. We'll discuss that. Okay, so we are good with this? Okay, now what is this? I want Naisha, you also start answering. Let me see how much you have understood. If you are learning few things in the class, that's more than enough for me. Is it a good conductor of electricity? This one? Can see the electricity here? Is this one a good conductor? But is it a non-conductor? It's not a non-conductor. You can see electricity, right? No, Naisha. Still some electricity. This is a non-conductor. So divide these things. This is non-conductor. Non-conductor means non-electrolyte, no ions. Non-electrolytes. Non-electrolytes are, so please write down what are non-electrolytes. Covalent molecules. Covalent molecules. Polar, non-polar, doesn't matter. Even water. Pure water is non-electrolyte. Pure water, if I give you pure water, 100% pure water, it will not conduct electricity. So covalent molecules are non-electrolytes because they don't have ions in them. You put them into water, they are soluble. So with covalent molecules, like I can write like this, C6H12O6 AQ. AQ means soluble. But is it an electrolyte? No, it's a non-electrolyte, right? Okay, okay, Aditi, no problem. So then we have this one. What is this? Is it a weak electrolyte or strong electrolyte? This one is weak electrolyte because you can see that you don't have that much number of ions in the solution. See, this one is undissociated. This one, undissociated, 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 but soluble. See, maybe this, you can say some weak acid, HF. Undissociated, but soluble. Undissociated, but soluble. Some part is dissociated, right? Okay. So that's the meaning of strong electrolytes and weak electrolytes for ionic solids, ionic compounds. We, and only ionic compounds are electrolytes. The word electrolyte is with ionic compounds. With acids and bases are also there, but that's a different story. Right now, I'm going to discuss that only. So first of all, you remember the names of acids we discussed in unit 1, how to do the nomenclature of the acids and bases. We spent so much time on that. So what are acids? What are acids, children? Any idea? Any one of you? Yeah. Acids are the one which gives you H plus ions. So they always start with hydrogen in front. Hydrogen, like HNO3, is an acid. H2SO4 is an acid. HClO4. Check the polyatomic ion list, which I gave you earlier also. And I'm going to give you right away again, because for this unit, this polyatomic ion list is very important. If you have not taken out the printout, then please do it. In this list, you can see all the acids also. Please download it. HNO3, H2SO4, HClO4, HClO3. All these are acids. No, Naisha, you have to practice it. Don't memorize. You have sufficient time to practice it. Every time, whenever I'm writing on the whiteboard, the formulas, just pull out this sheet. There is no need of memorizing anything. Don't memorize. Understand, practice with questions. So there is no need of memorizing, but yes, you should know it. So practice. Yeah, you will get periodic table. You will get periodic table, you will get formula sheet. Formulas will be there. Yes, Liza, thank you very much for answering her questions. So these are acids. I'm writing few more acids. HF, oh, not HF. I'm taking some particular category. HCl, HBr, HI. The acids which I have written here, they fall in two categories if you remember. Oxy, oxygen containing, non-oxy. Generally, I'm using the word oxo. I think in the list I'm using oxo acids and non-oxo acids. With oxygen, without oxygen. The list is there with you. And the one which I have written here, 1, 2, 3, 4, 5, 6, 7. These are the one which are strong acids which you need to know for your AP exam. Strong acids means they are 100% dissociated in water. You take this H2SO4, put this H2SO4 aqueous. What does it mean? All acids are soluble in water. Anything starting with hydrogen, soluble in water. Okay, so they all are aqueous. But once they are in the water, because you see they are non-metal bonded with non-metal type of kind of thing. So few of them are dissociated. Few of them are not dissociated, depending upon the type of the acid. H2SO4 fully dissociated as H plus aqueous plus HSO4 minus aqueous, fully 100%. So what is it? A strong electrolyte. So can I say all strong acids are strong electrolytes? Strong electrolytes. Can I say that, children? Is it okay? All strong acids. These are the only six, seven, which you, in fact, they say only six, but I'm giving you seven. Let's go for seven. Seven is a good number, and HClO3, everybody knows, is a strong acid. All strong acids are strong electrolytes. These are the only seven formulas, names you should know. Do you know the names? What's the name of this acid? Oxo acids, they never start with hydro. Yeah, no hydro. The way Aslisha is saying. Nitric acid. The name, this one? Sulfuric acid. Sulfate, sulfuric acid. This one? Perchlorate, perchloric acid. Perchloric. This one? Chloric acid. This is chlorate ion. Chlorate will give you chloric. Perchlorate will give you perchloric. Sulfate will give you sulfuric. Nitrate will give you nitric. Carbonate will give you carbonic. So it's very easy. I have given the list and I think I discussed this earlier also. What's the name of this acid, children? Now this is non-oxo. Hydrochloric, yes. Hydrochloric, hydrobromic, hydroiodic. Can you name this, Afan? This one? This one? This one? Hydrocyanic, hydrofluoric, hydrosulfuric. Now I'm writing few things here. You can check the ion in the polyatomic ion list. This is acetate ion, acetate. So what is the name of this acid? Acetic, acetic. Then there is phosphate ion. So what's the name of this acid? There is carbonate ion. So what's the name of this acid? This is acetic acid, very popular acid. You should know it. Is vinegar in your kitchen? In the kitchen, your mother is using vinegar for cooking. That vinegar is diluted acetic acid. It's not concentrated, hardly 10%. In that vinegar, kitchen vinegar, we have only 10% of acetic acid. Rest is water. Phosphoric acid, carbonic acid. Naisha, you have seen vinegar in your kitchen? Vinegar? Yeah. Naisha, what about you? Today you are going to check with your mother, okay? Just ask her to show you vinegar and just tell her the formula and tell her the name. That's how we can learn, right? Rather than memorizing, we should practice like this. Okay, this is phosphoric acid. This is carbonic acid, right? Yes, it is called as acetic acid. Yeah, here. Okay, so now the acids which I have written here, they are weak acids. Weak acids. Weak acids are soluble in water. They are completely soluble in water because they are acids, so they are soluble. But they are not fully dissociated. So let me give you the rules for the weak acid. These are the only strong acids which you have to practice. But for the weak acids, we have some rules. You're writing here? I'm writing these rules here. So please write down the rules. Oxo acids which are weak. How to identify them? First, they are carbon and C means carbon. Carbon and phosphorus containing. If you see carbon and phosphorus in the formula, weak acid. Second, they should be ending with us. Sulfurous, nitrous, chlorous, hypochlorous. These are weak acids. They are ending with us. In oxygen containing, please write on this rule. Weak oxo acids are these. Easy to identify. And non-oxo acids, the rule is very simple. In non-oxo acids, you have HCl, HBr, HI as Strong acid, you see, I've given the list as strong acids. And they say, other than this, rest all. You see any other non-oxo acid? Non-oxo means without oxygen. You see any other non-oxo acid? Rest all are weak. Write down these rules. They are going to play a very important role in Unit 8. So are we clear about it? Now, check this container. Is it a strong acid, weak acid? This one, children. Is it fully dissociated or partially dissociated? Fully. Strong acid, strong electrolyte, right? Now check this one. This is your vinegar, acetic acid. See color code, hydrogen, oxygen, carbon. Is this dissociated one or undissociated one? This one. This is this one, undissociated. Yes. And this one, this is the dissociated one. So let's write down the equation for dissociation of this acid HCl. So I'm writing the equation for dissociation of HCl. It's aqueous, means it's in water, soluble. It's going to dissociate completely. Single arrow, single arrow. H plus, aqueous, Cl minus, means after the dissociation, HCl is zero there. There is no HCl. You can see that. They are completely in the form of ions, right? So you put single arrow because there is nothing of this. But here in this example, it is slightly dissociated, only slightly. Most of it undissociated. You can see the undissociated one here. This, 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 this. Out of 5, only one is dissociated. It's a very weak acid. So when you are writing for this, then you have to put double arrow. A double arrow means weak electrolyte. So whenever you are dealing with a weak electrolyte, which is not fully dissociated, you have to put a double arrow like this. But it's aqueous, it's soluble. All acids are soluble. But this one is not fully dissociated. AQ and H plus AQ. That's the dissociation of this weak acid. These are weak acids, all of them. These are the rules for weak acids. So you can easily identify it, right? Can I ask a question now? Okay. I'm going to erase this. I hope you have written this. Okay. HF. Is it a strong acid or weak acid? Remember, I gave you 3 non-oxo strong acids and I said rest all are weak. It falls in rest all. It's weak. So should I put a single arrow or a double arrow? A double arrow. Like this. Is it soluble in water? Not soluble. All acids are soluble in water. So what should I write? AQ, because it is soluble in water, right? Now it's going to dissociate. Some of it, like this, some of it, not all of it. So what should be here in the dissociated form? Mhm. What should I write when it dissociates? This hydrogen has 1 plus and fluorine has 1 minus. Yes, H plus, H plus aqueous and F minus aqueous. Now, I'm giving you a beaker. The way this beaker is there, I'm also giving you a beaker. In the beaker, there is water. So I'm making water here, children, with aqua color. This is the aqua color, this one. Okay. This is water in the beaker. Now I'm going to put HF in this solution. In this, I'm going to add some HF. I'm adding HF. So can you tell me what all will be there in the beaker, the way they are showing? You just give me the formulas. I'll put the formulas here. What all will be there in the solution? Mhm. Do I have HF in the solution? Yes, because it's not dissociated completely, so HF is there. What else? H plus and F minus. When you are showing it in the water, there is no need of showing that aqueous, right? See, it's surrounded by water, surrounded by water, surrounded by water. In the picture, we don't write AQ. Is it okay? This pictorial representation. So what all is there in the solution, children? What all is there? HF, H plus, F minus. One more thing. Anil, one more thing. What is that? Yes, water. Water is also there. So if they are saying write all the major species of the solution, please do not ignore water. It's also there, right? Is it clear to everyone? Now, let's go for strong bases. The rule is very simple. The hydroxides OH minus, yes, they give OH minus. Yes, Anil. Bases, they give OH minus in water, which is called as hydroxide. You can check my polyatomic ion list. Hydroxides. The hydroxides of first group metals. First group metals. You know first group metals, children? Yes, Ashleisha. Any metal from the first group? Sodium, lithium, rubidium, cesium, all these. They are hydroxides. So what will be the formula of their hydroxides? Sodium hydroxide, because Na plus, oh, this is 1 minus. Lithium hydroxide, potassium hydroxide, cesium hydroxide. I'm not writing in the order, but all these are elements of the first group, right? I'm not talking about francium because francium is radioactive, so let's leave it. So these are, what are these? These are strong bases, all of them. And they are completely 100% dissociated. See here, NaOH, NaOH. Can see 100% dissociated. You can see every ion is separated. What is there around every ion? Water. Ion dipole attractions. Ion dipole attractions, right? It's completely 100% dissociated. And the second is, look at the second period. Leave that last element, which is radioactive, and that is, I think, radium. Can you name the three elements above it? Three elements above radium. Any one of you? You have the periodic table next to you? Mhm. Yes, but the formula, Anil, is wrong. It's a second period element. They are calcium 2 plus, strontium 2 plus, barium 2 plus. So their hydroxides will be calcium hydroxide, strontium hydroxide, and barium hydroxide. These are the strong bases. The rule is very simple. Rest all are weak. It's a very simple rule which you can memorize, right? Practice and memorize. Like if I say ammonia is a base, so what do you think? Is it a strong base or weak base? Because it falls in rest all category. It is not the part of your first group metals. It is not the part of these three elements of the second group. So what is it? It's a weak base. So weak base is going to dissociate completely. Weak base is going to dissociate completely or not completely. And then answer this question asked by Anil. He is asking a question, children. I'm expecting you people to help me out. MgOH twice. He's saying, is it strong or weak? Follow the rules. Is Mg2 plus here? Is it there? No. So what is it? Weak. It's a weak base. Weak base is not fully dissociated. So if it is clear, if you have written everything, can I erase this? Only Anil is interacting with me. Afan, question for you. I'm giving you some bases here. You have to identify them as strong or weak. So these are the bases. Can you identify what kind of base is this? Strong, weak? I want answer from all of you, not only Anil. Hmm, very good. What about this one? What about this one? Yes. So these are simple questions. You have that list of the strong acids and weak acids, strong bases, weak bases. You have so many months to go for your AP exam, nearly 6 months, right? Am I right? Maybe 5 months, we can say 5, 6 months. So you take a printout of that list, take a printout of the periodic table, polyatomic ion list, keep it on your table. Now it will be very high time that you'll be practicing many questions. So every time you check this list, I'll give you solubility rules also. And then you check the list and try to answer your questions. And you will see that without memorizing, you will become expert in answering these questions because practice will make you memorize, right? But for that, you should have the printout on your table. Okay. So ammonia is a weak base. See, this is ammonia. Look at this. What's the formula of this compound? This one. Use the color code. What's the formula? NH3. This is also NH3. You remember NH3 can make hydrogen bonding. So NH3 is soluble in water, right? These are NH3. So this NH3 is soluble in water because it can make hydrogen bonding. You add water and then it's a weak base and it's a base because it's going to give you OH minus. So don't worry about the equation. Equation you are going to learn in unit 8. So I'm giving you the complete equation. So you can see OH minus here. So it's a weak base. We are good with this? Understood? Okay. Now I'm taking you on the next last of this electrolytes, non-electro. Now the last is non-electrolytes. I already explained you. Do you think non-electrolytes can conduct electricity? No. So non-electrolytes are covalent molecules. Molecules. Question for all of you. The question for all of you. C12H22O11. This is sugar. Is it soluble in water? Is it soluble in water? Sugar is soluble in water, we all know. And is it going to dissociate into ions? No. So can I write C12H22O11 as AQ? Because it's soluble, right? But you are not going to get ions. So is it going to conduct electricity? That solution will conduct electricity? No. So what is it? Non-electrolyte, non-conductor of electricity, no ion formation. Okay. Now I'm giving you some compounds here. You have to identify them as weak electrolyte, strong electrolyte, and yes, Anil, all organic molecules, all covalent molecules. I'm giving you a list of some compounds here. Identify them as strong electrolyte, weak electrolyte, and non-electrolyte. Strong, weak, non. Yes, please. What is it? We have less time, so we can do it fast. Only 1 minute. It's a weak acid. So, weak acid means weak electrolyte. We did this example. What is this? It's a base. Strong base, weak base. Weak base. So, weak electrolyte. What is this? It's an acid. Remember, I gave you 7 formulas. It is one of them. So, strong electrolyte. What is this? It's neither an acid nor a base. It's an organic molecule. You see, non-electrolyte. What is this? It's an ionic compound of the first group. It's a strong electrolyte. In the next class, we are going to do net ionic equation and the solubility rules. We'll revise something about molarity. That's not going to take much time. More important is this, solubility rules. Okay, so I'll see you then in the next class.